Bismillahirrahmanirrahim. Assalam O Alikum. Dear students, welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus KPK Book Foundation Physics SSC 2. Unit number 13 Electrostatics. According to SLO base or FBISC requirement, numerical problems question number 10 to 13 in part 4. Let's start the today lesson in numerical problems question number 10. According to the given statement, the potential difference between the 2 points is 110 volt, and when an unknown charge is moved between the 2 points, the work done is 550 joule. What is the amount of charge? Here, according to given statement, the potential difference delta V is given that 110 and work done that is equal to 550 joule. We can find that amount of charge that is equal to Q. Now, according to the given statement, first of all write the given data. In given data, potential difference V is equal to 110 volt and work done that is equal to W is equal to 550 joule. We can require that amount of charge that is equal to Q. Using the formula, we know that W is equal to QV. This implies that Q is equal to W upon V. So let's start the solution. We know that Q is equal to W upon V, then putting the value. So Q is equal to 550 divided by 110. Now 550 divided by 10, that is equal to 5 coulomb. This implies that the amount of charge Q is equal to 5 coulomb. Now move the next numerical problem in question number 11. The given statement of question number 11, the capacitance of a capacitor is 3200 picofarad. If the potential difference between the two plates is 220 volt, what is the charge on each capacitor? Here we can find the charge on each capacitor. So according to the given statement, write the given data. In given data, capacitance that is equal to C is equal to 3200 picofarad. So this implies that C is equal to 3200 multiplied by 10 raised to power minus 12 farad. Here 1 pico is equal to 10 raised to power minus 12. And also given that potential difference that is equal to 220 volt. We can require that charge on each plate that is equal to Q. We have using the formula that is equal to Q is equal to CV. So we can find the solution. We know that Q is equal to CV, putting the value. The value of C is 3200 multiplied by 10 raised to power minus 12 multiplied by 220. Here 3200 multiplied by 220 volt. So we can change the answer in microcoulomb. Then Q is equal to 0.704 microcoulomb. Now let's start the next numerical. In next numerical problem, question number 12. There are three capacitors in a capacitance of 1 microfarad, 2 microfarad and 3 microfarad are connected in series to the voltage of battery 110. Calculate the equivalent capacitance and the voltage across each capacitor. Now we will find the answer according to the statement. Write the given data. Capacitance of capacitor C1 is equal to 1 microfarad. That is equal to 1 multiplied by 10 raised to power minus 6 F. Here 1 micro is equal to 10 raised to power minus 6. Similarly, capacitance of other capacitor that is equal to C2 is equal to 2 micro F, that is equal to 2 multiplied by 10 raised to power minus 6. And capacitance of next capacitor that is equal to C3, that is 3 micro F. So 3 multiplied by 10 raised to power minus 6 F. Now the voltage of battery that is equal to V is equal to 110 volt. We can calculate the capacitance of equal capacitance that is denoted by CE, and voltage across capacitance of C1 that is equal to V1. Voltage across C2 that is equal to V2, and voltage across C3 that is equal to V3. We can calculate and find the remaining value. So we can find the solution. First of all, write the series combination of the equivalent capacitance. So equivalent capacitance in a series combination, 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Putting the values 1 upon 1 plus 1 upon 2 plus 1 upon 3, that is equal to 11 upon 6. Calculate the value. So 1 upon equivalent capacitance that is equal to 11 upon 6. Now taking the reciprocal, here C equivalent is equal to 6 upon 11. That is equal to 0.54 micro F. So this value is equal to 0.54 multiplied by 10 raised to power minus 6 F. Similarly, for a series combination having the same charge, so Q is equal to Q1 is equal to Q2 is equal to Q3, because in a series combination charge will be same. So Q is equal to Q1, that is equal to Q2 and also equal to Q3. Now Q is equal to C equivalent multiplied by V. Putting the value of C equivalent that is equal to 0.54 multiplied by 10 raised to power minus 6 multiplied by 100, and so 0.54 multiplied by 110, that is equal to 60 multiplied by 10 raised to power minus 6 coulomb. Now we can find the capacitance of the voltage. So here first of all, for C1 we can calculate V1 is equal to Q upon C1. Then value of Q is equal to 60 multiplied by 10 raised to power minus 6 divided by 1 multiplied by 10 raised to power minus 6. 10 raised to power minus 6 cancel by 10 raised to power minus 6. So V1 is equal to 60 volt. Similarly, we can also find that V2 and V3. Here V2 is equal to Q upon C2, that is equal to 60 multiplied by 10 raised to power minus 6 divided by 2 multiplied by 10 raised to power minus 6. 10 raised to power minus 6 cancel out 10 raised to power minus 6. So 60 divided by 2, that is equal to 30 volt. So V2 is equal to 30 volt. And V3 is equal to Q upon C3. So 60 multiplied by 10 raised to power minus 6 divided by 3 multiplied by 10 raised to power minus 6. 10 raised to power minus 6 cancel by 10 raised to power minus 6. 60 divided by 3, that is equal to 20 volt. So V3 is equal to 20 volt. More numericals and more videos, subscribe our channel. Best of luck. Allah.